Okay, I'm going to do problem 3 from last semester's exam. It says a condenser microphone uses a capacitor as its transducer. The transducer is just the thing that converts sound waves into an electrical signal. The potential difference across the capacitor is held fixed at 48 volts. The capacitor is circular with a diameter of 2 centimeters and has a capacitance of 50 picofarads. So the first question is, what is the charge density on the plates? The charge density, you guys use the symbol eta, is this just the charge per total area. So you need to find the total charge. The area you can find, since that it's a circular capacitor with a diameter of 2 centimeters. So the total charge is the capacitance times the voltage on a capacitor. So you know both of those, and the area is pi times the radius, which is 1 centimeter squared. So if you do this, capacitance is 50 picofarads. The voltage is 48 volts divided by pi r squared. And if you calculate that, you'll get 7.64 microcoulombs per meter squared. So this is a charge per area for the units. All right, what is the electric field E between the capacitor plates? So you know what charge is built up on the plates. You found that in the first part. It's C times V. And so if you know the charge on a plate, and you always assume that these capacitor plates are infinitely large plates. So the field between two infinitely large charged plates is the charge density over epsilon naught. You found the charge density here, so 7.64 microcoulombs per meter squared, and epsilon naught is this 8.854 times 10 to the minus 12, and that is farads per meter. So this is 8.63 times 10 to the 5 volts per meter. And so for this part, you just needed to know this equation. This is the electric field between two charged plates. Okay, and now what is the separation D between the plates? So you know the electric field between the plates. You know the potential difference between the plates because that was given to you. And so between these plates, the distance D, this is your electric field E. So the potential difference is just the electric field times the distance between the two plates. So the separation is volts, the potential difference divided by the field strength. So the potential difference was 48 volts. And the electric field between the capacitor plates you found in this part here. And so you're going to get something in meters. And the answer was, let's see, 56 micrometers. So 56 times 10 to the minus 6 meters. Okay, and then this last part is qualitative. So they say the microphone described above produces a signal when air pressure from a sound wave decreases the separation of the plates. So just a sound wave comes in and compresses these two capacitor plates. So circle whether the properties below increase, decrease, or stay the same when the separation decreases for the capacitor. Okay, so the potential difference, it says in the beginning of the problem, is held fixed at 48 volts. So no matter what we do, the potential difference is fixed. So this stays the same. The charge on the capacitor, let's see, the charge is Q equals C times V, where V is fixed. So the charge is going to do whatever the capacitance does. So if the capacitance goes up, then the charge is going up. So we need to figure out first what the capacitance does when the two plates move together. The capacitance we found, let's see, what's the best way to explain this? Okay, so we know, let's start with E field actually. We know that if we move these plates together, then this distance between the plates has gone down, but the potential's the same. So that means that the E field had to increase. So if the E field increases, then we know that, so we did on like this part here, we found the electric field between the capacitor plates is this charge density over epsilon naught. So if the electric field increased, then we know that the charge density must have increased. So if the charge density, the total charge increases, then we know that the capacitance must also increase because V is fixed, Q went up, so C has to go up. And the stored energy is like 1/2 CV squared. So if V is fixed and C goes up, then the energy will also increase.